So for pressurized double wall lines, you have two options. You either need to have a continuous monitoring system that activates an audible visual alarm, such as a electronic monitor, or you have a continuous monitoring system that stops the flow of product at the dispenser when a leak is detected. Okay? To me, this was confusing when I first read it because it's not giving you an option for the whole system versus another option for the whole system. But that second box is allowing for the dispenser monitoring that's not necessarily electronic and is not necessarily hooked into the main panel. So you could have let me give you an example. Let's say you have the Veeder-Root electronic 208 sensors within your Sumps, and that's monitoring your piping, and that's hooked into a monitor which will activate an audible and visual alarm. But what about your UDCs that might have the standalone sensors, floats and chains? So this second option allowed Couplus to capture that monitoring device for UDCs. Is that clear? So it's not either or per system, but it lets you apply either or within your system. So you might have half your system fall under the first box and the other half of your system fall under the second box. Because what was happening, I think the state added this after the fact, that if you left it as continuous monitoring that activates an audible visual alarm, it wasn't taking into account all of the UDCs that sometimes have the standalone sensors, which only stop the flow of product at the dispenser. So those are electronic, but they're not tied into a monitor system. And they also don't take into account your floats and chains. Okay? So in addition, you're going to need a line leak detector. There's no way around that. And you also need an annual 0.1 gallon per hour piping test. So that's it. Those are the requirements for double wall pressurized piping. However, there are some options. If you would like to do something else instead of having to do that annual 0.1, you have the options of having pump shutdown, which means your continuous monitoring system will shut down the pumps or stop the flow of product at the dispenser when a leak is detected. And continuous monitoring for all product piping located outside the UDC is fail-safe, and it will shut down the pump when a leak is detected. Okay? We don't have a single site in San Diego that does an annual 0.1 gallon per hour test. Every site uses these second options. In fact, it's so common that we forget that the actual initial requirement is to do an annual 0.1. It's like you don't have pump shutdown, that's a violation, but really it does not necessarily have to be a violation. As long as they have the 0.1, which is the actual original requirement, then they're good. But most facilities opt out of the 0.1 and have the pump shutdown, which basically means if you're testing your Veeder-Root, I'm trying not to use brand names, but it is what we see most often. But if you're trying to test a sensor in the piping sump, it needs to shut down the turbines when it detects a leak. And it's only required for the product piping STP sumps. Do any of you guys have sites that do the 0.1 and they don't opt out? No? It's easy. But with that being said, if that's how they decide to monitor the system, it needs to be functional. So it needs to have shut off, but you can have potential issues with stuck relays or improper programming. So there are potential downfalls for that. So I mentioned the words fail-safe, and what is that exactly? And it means that a monitoring system will shut down the turbine pump in the event of a power outage or when the monitoring system fails or is disconnected. So that's the other required item you need if you're going to not do the annual 0.1 test. Okay, any questions before we move on? Nope. Am I being clear? Are you guys just tired after lunch, or? Hopefully I'm being clear. So I just wanted to show you a few pictures of, I was using some terms. Monitoring panel, here's an example, TLS 350 Veeder-Root, we see that all the time. Continuous monitoring, the electronic variety, common 208 sensor right there on the right side. It's a typical float sensor. And then I mentioned that option that was written in to accommodate those sites that might have under dispenser containment without electronic monitoring. So here's that same picture that Zoraida went over the process for standalone sensors. So this is electronic, but it's not hooked into a panel. It's just going to stop the flow at the dispenser, and she showed you that in her presentation. And then here's mechanical float looks like, and the idea here is that if there was a leak, it would fill the UDC, it would fill this area right here, which in turn would push up that float, and that float is hooked onto the shear valve here with this chain, and the idea is that it pushes the float up enough that it pulls the chain and shuts off the flow at the shear valve. So during our annual inspections, we're doing these tests, from a functionality standpoint, where we're actually pouring water into these UDCs to make sure that the floats actually work. So during the inspections, you're also looking to make sure the chain's actually connected, it's actually there, and it's got a tautness that's going to allow the float and chain to work as it should. Okay, so I'll move on to double wall emergency generator system piping. So a lot of the similar types of monitoring you're going to see over and over here. The same thing with continuous monitoring. It needs to activate an audible visual alarm, or it needs to stop the flow of product when a leak is detected. I have not seen the option, because keep in mind emergency generator systems don't have UDCs for the most part. They're a little bit different types of systems, but I imagine most of them are hooked into option number 1 only because you really don't want an emergency generator system to have any reason to shut down on you. We had a situation in San Diego County. We had pretty much a county-wide power outage back in September, and there was a hospital on emergency generator power. I don't know if you guys heard about this at all, but they basically had 3 different issues with the Veeder-Root, how it was programmed, and they basically they lost their fuel source for about 45 minutes. So I think they ended up having to move people to different hospitals, and they finally did a manual override. But bottom line is, the less electronic parts you have for a system such as this, the better. So I imagine an audible visual alarm would be the best option. And I personally haven't dealt with a system that has this as the option. And of course, you need a continuous monitoring system. It needs to be checked at least daily. And I know for a lot of sites that have emergency generators, they have their own SOCs that, this one hospital I was talking about, they check 9 times a day. So that's their own protocol. And of course, they need an annual 0.1 gallon per hour piping test. But they don't have an option to opt out of that. They still need to get that done. Whoops. But if you notice, they don't have a line leak detector requirement. So for those of you that have been around, this reminds us of how the monitoring requirements used to read pre-94, where everybody needed or if you didn't have a line leak detector, you had to have the 0.1. And then in 94, I think it's November 9th, 1994, they all needed line leak detectors, so this requirement was no longer needed. But since there's no line leak detector requirement, you still need to do the annual 0.1. And I imagine there's no line leak detector requirement because A, it's double walled as opposed to the single wall generator piping, which did need a line leak detector, so it's a little bit less risky. And at the same time, you want to have fewer moving parts for a system that does deal with the emergency components of a facility. And then, like I mentioned before, if emergency generated piping is unburied, it's excluded from these requirements. and I showed you that example from one of the hospitals that would have met the exemption for the exclusion. Okay, so requirements for double wall suction piping. Two options. They can have continuous interstitial monitoring for piping and UDC that activates an audible visual alarm, or they can have continuous monitoring for both piping and UDC that stops the flow at the dispenser when a leak is detected. Yes. The question is, does my personal definition or the definition I put up earlier with single wall? San Diego? Depends. No, technically it does not. We've had, the question is in San Diego County specifically, do we treat the boiler and emergency generator the same? Is that right? Yes. The question is, if you have a tank that feeds both a boiler and an emergency generator system, is that tank qualify? We've had a scenario where we made the decision that that piping did fall under the same rules only because that boiler piping was only used in emergency services. So we've had other instances where that boiler that's served by a tank, it's not used in emergencies, so it's not considered. So I don't mean to be facetious when I say it depends, but it really does depend because it depends on the use of the boiler. That's how we've treated a few specific scenarios. How does everyone else define it? How about you in your county? How do you define that? Would you also consider it the same or completely different? Right. So you're with a fire? Doing what we do, if it does service in an emergency, it would be monitored in such a way. Emergency generator. Anyone do anything different? I mean, our bottom line is we don't want to be responsible for a non-functioning fuel tank in an emergency. So in those situations, it is case by case. We want it to be within the code, within the law. However, it needs to make sense in a real world application. So, in our situations, I feel like we've come up with solutions to address stuff that's, in the gray area. It's not black and white. And when in doubt, do a .1. That's our motto in San Diego when you're not sure what to do. Let me give you this. I mean, the more documented, so he's asking if there should be documentation if you have an unusual situation. In San Diego, usually like that, our program, the UST program comes in, will help out regardless. documentation is always a good thing. We don't have any specific requirements in terms of that, but a lot of it's determined through inspections, and then we often document ourselves within files within our computer database. And if there is anything that's a little bit off, we do document, whether it's coming from the business owner or from ourselves. Any other questions? Right. None of the options require a PLLD line leak detector. It says alert, audible visual alarm. Anything else? In terms of the whole presentation? Well, don't forget, the question was for emergency generator and STP piping, if you have the option of not having it shut off, you always have that option. Question. The question is, can you set a 208 sensor in an STP sump for an emergency generator system to not have shut off? And my initial inclination would be yes, because you have the option of doing a 0.1. Then the other part of the option is fail-safe, and that's also not a requirement for emergency generators. But let me go back to the options. It looks like if you go with the box number 1, you do have that option. You just need continuous monitoring. And you're talking about double wall, right? Yeah. Okay. It sounds like you would go with the option number 1, which is continuous monitoring that would just alert with an audible visual alarm. So it doesn't require pump shutdown specifically. So did everyone get a copy? I don't know if there's any stragglers or latecomers, but all these alternatives are in the handout in the back. So if you guys don't have that, it's back there. Okay. Is there another question? No? Okay. Did I do suction piping yet? I don't remember. I'll do it again. So for suction piping, double wall, we're still in double wall. Continuous interstitial monitoring for piping and UDC that activates an audible and visual alarm. Or, similar to the other one, you can have stops the flow at the dispenser when a leak is detected. So it's giving you that option once again. If you don't have an electronic sensor in your UDC, you have your non-electronic options. Okay, and last but not least, we have double wall gravity piping. So your requirements for the double wall gravity piping are going to be either continuous monitoring for piping and UDC that will activate audible visual alarm, or same as all the other ones, both the piping and UDC, you need to stop the flow at the dispenser when a leak is detected. So you start seeing a lot of the same ones, and this table is really nice because it really breaks it down. You know, my philosophy is you start with the date, and then you look at the type of system, and that's really going to help you narrow down your requirements and what you need. Okay, so I'm going to talk about the sensors, which is going to aid in the continuous monitoring just a little bit here. So this is where you're going to find them. You're going to find them in the secondary containment. So what they do is they're going to detect presence of fuel and or water in the containment sumps, okay? And you're going to find them in tank top sumps and UDCs. And of course, with newer installs, you're going to have transition sumps, and there's always a few systems that are not typical, but a sump is a sump. So here's an example of a Ronan sensor within a STP sump, also known as piping sump. And I just want to differentiate between your non-discriminating sensors and your discriminating sensors. So with non-discriminating, such as a Veeder-Root 208 float sensor, which we'll have some pictures in just a minute, it's going to use a single detection element, often a float switch, okay? And they don't differentiate between fuel and water or really anything else because it's a float. It's going to go up or it's going to come down, and it's going to activate the alarm once it goes up, okay? We see that San Diego most commonly anywhere between 85 and 90% of our sites. And then you have your discriminating sensors, which you've seen various types, and I'll show you some pictures, but they're going to differentiate between fuel and water. And sometimes they can give you different types of alarms for each, and they can have multiple mechanisms within the actual sensor. So you might have a float switch that will detect water or anything else, Kool-Aid, what have you. And then you're also going to have another element that can detect fuel, and oftentimes they're not detecting liquid fuel, they're detecting the vapors. Okay, so these are less common, about 5 to 10%, and oftentimes when these sensors start breaking down, stations or facilities will start opting out to replace them with non-discriminating. So here's a couple visual examples. It's hard to tell with the lighting in here, but you have your non-discriminating example on the left, typical 208 sensor, and that's a cutaway showing the actual float. And that's what's going to go up and down to activate that alarm. And then discriminating, you oftentimes have a float about halfway up, and then it's hard to tell, but there's sometimes a strip here that will pick up any of the hydrocarbon vapors, and that's what will activate that fuel alarm. And then down here on the right is another discriminating. It's part of the Boudreaux system, and there's about 5 different nodes on here, and they can also, this is more of an optic sensor, and it's going to discriminate between fuel and water as well. So what are some problems? And these problems, are across the board. They're going to affect discriminating sensors, non-discriminating sensors, but most common, we have the tampering issue. They're raised from the low point, they're disconnected. Oftentimes it's found in combination with some sort of liquid in the sump. Unfortunately, they kind of go hand in hand. And then at times you have them left up based, because they were doing secondary containment testing at this facility, and they just forgot to put them back in the low point. Then, of course, you can always have wiring issues. You're going to find that with any electronic component. They can be shorted, corroded, disconnected. We see them spliced in quite a bit. And then you can have non-functional pump shutdown. And remember, pump shutdown is not a requirement. However, if that's how it's being programmed and that's the option that they've chosen, it needs to be functional. And some issues there can be stuck relay or improper programming. And you find that more commonly than you would think. Improper use of a sensor. We see that every once in a while. And then, of course, there's the human element of sensor being an alarm and it's ignored. You just hit that red button over and over again. You don't, becomes a non-issue. So here's a example of what you might see with a raised sensor. And like I said, it often goes hand in hand with some sort of higher liquid levels. If you were to put this in the low point, which it has a nice little cup holder here, it would most likely go into alarm. So when we see stuff like this, we document, we take pictures. you want to look at the surrounding situation. Sometimes it's very obvious what's going on, sometimes not so much. And then sometimes it is obvious that it was accidentally left due to testing, and that can all be tracked with records and stuff. Okay, so a little pop quiz here. I know you guys are probably exhausted after lunch, and talking about USTs for the last 5 hours, but what is the difference between a safe suction system and a conventional suction system? Check valves, that's right. So safe suction does not have the valve in the buried piping. Remember, it's going to allow the fuel to drop back to the tank. What type of piping is excluded from the definition? What type of piping is excluded from the definition of underground storage tank per section 25281.5B3? Wait, associated with what? So he said above ground? Right, but it's connected with the emergency generator. So yeah, but you're right. It's and often your exclusions are going to be above ground, whether it's a generator, whether it's marina piping, or well, those are the two above ground issues. Okay, so what type of piping systems require an automatic line leak detector? Right, so we have pressurized system. The exception being a double wall pressurized systems associated with emergency generators. Okay? Okay, so if a double wall pressurized pipe system is not programmed for fail-safe, what's required? Point one. When in doubt, point one, right? So point one was the right answer. Because don't forget, that's the actual initial requirement. Fail-safe and pump shutdown are in lieu of that at the discretion of the operator. Okay, I'm going to have some water real quick.